Steel. The world as we know it today is simply inconceivable without this timeless material. Steel vouches for stability and safety. Steel ensures that raw materials and goods can be transported around the world. Machinery and equipment are made of steel, and steel ensures environmentally friendly energy production. Today, more than ever before, steel is a high-tech product. From ore to steel. Steel production at Salzgitter Flachstahl. Ore is the basic material used in the production of iron and steel. Today, Salzgitter AG sources its ore from all over the world. The raw material is transported by ship and rail from Scandinavia and Russia, as well as from Canada, South America, Africa and Australia. We not only process lumps and fines, but also pellets. These consist of concentrated iron ore that is fired to form small spheres, which are particularly easy to transport, store and process. The Salzgitter location has several blast furnaces for manufacturing pig iron. The largest is more than 50 meters high, which is equivalent to a 15-story building. Up to 14,000 tons of pig iron can be produced each day. Pig iron is produced inside the blast furnace. Coke and ore are transported from bins to the blast furnace. With the addition of lime, these materials are then charged into the furnace in alternate layers by means of a rotary chute. The layers sink down the shaft of the furnace. The ore is heated, reduced and then melted by rising process gas. Process gas is generated when air, preheated to approximately 1,200 degrees Celsius, is blown into the furnace. The oxygen in the air burns with the coke, generating process gas with a temperature of about 2,000 degrees Celsius. It removes oxygen from the iron oxide and the heat melts the iron. The whole process takes 8 hours, and the resulting liquid iron and slag collect in the lower part of the furnace. Tapping takes place about every 2 hours. The pig iron and slag flow through the tap hole under pressure and at a temperature of about 1,450 degrees Celsius. The slag is now separated from the iron. Initial samples are taken to determine the quality, the work of professionals who have to wear protective clothing. The torpedo ladle cars are ready and waiting 1 story below. They owe their name to their elongated form. The Salzgitter Flachstahl steel mill is a gigantic hall that is more than 400 meters long. About 480 detached houses could fit into this space. Pig iron is poured from the torpedo ladles into transport ladles, each of which has a capacity of about 200 tons. In addition to pig iron, scrap is also used in the production process. Both are poured into a converter. The Salzgitter site has 3 LD converters. With the LD converter method, technically pure oxygen is blown into the converter via bottom porous plugs, as well as via an oxygen lance. The red-hot molten pig iron is heated further, and any unwanted tramp elements pass into the flue gas. This process is known as carbon drop. Extremely high temperatures of up to 3,000 degrees can theoretically be generated. To prevent this, the converter is filled with chill scrap. As a result, at the end of the converter process, the temperature is about 1,700 degrees. In total, the converter process takes about 40 minutes, and at the end of it, the pig iron has been converted into crude steel. Each of the 3 converters has a capacity of 220 tons. Up to 12,500 tons of crude steel are produced at the Salzgitter site each day. Not all steel is the same. Depending on the intended purpose and customer specifications, alloying elements such as manganese, silicon, chromium, nickel, titanium and molybdenum are added to the crude steel in the VPL plant in order to produce individual and high-grade steels. These steel grades are supplied to the continuous casting lines, which create so-called slabs from the liquid steel. The casting now has a solid shell a few centimeters thick, while most of the cross-section is still liquid. The casting is torch cut into slabs for dispatch. The slabs are up to 35 centimeters thick and weigh as much as 32 tons. Some of these slabs are taken to the sister company Ilsenburger Grobblech, where they are rolled into sheets for use in wind towers. The majority of the slabs are transported to the hot strip mill. Here they are heated in the furnaces of the hot strip wide mill to a temperature of about 1250 degrees. They can then be rolled into wide strip. The advantage of hot rolling is that the rolling stock is softer at higher temperatures and so less force is required for rolling. In the first rolling cycle on the blooming train, the red-hot slabs are rolled on a reversing mill, becoming thinner and longer each time they pass through the mill. They then pass through the finishing train. After several rolling cycles, the resulting hot strip is up to 2,000 meters long. After processing in the mill train, this is wound into a coil. Some of this material is further processed within the group, for example for the production of large diameter pipe. In the hot strip cut-to-length line, the hot strip is cut into steel sheets. The sheets are up to 16 millimeters thick and are used, for example, by customers working in mechanical engineering and special vehicle construction. The pickling line descales the surface of most of the material. A very large range of products can later be produced from this material. Sheet thicknesses of less than 3 millimeters are produced in the cold rolling mill. The central section of the cold rolling mill is the 5-stand tandem mill. The pickled strip is rolled in a single pass to finished thicknesses of between 0.35 and 3.0 millimeters according to customer specifications. At this stage, final rolling speeds of up to 90 kilometers per hour are achieved. A process computer processes the measured data obtained from the entire rolling train and controls the rolling process. The annealed coils are then transferred to the skin pass mills, where they are passed through special rolls and provided with a predetermined surface roughness on the sheet. In this way, subsequent formation or the application of paint or other coating materials is improved. The coils are later used in the production of drums, for example. The Electro-zinc coating line processes cold-rolled sheet steel in electroplating cells. An electric field between the sheet and the anodes causes the zinc, dissolved in the electrolyte, to be deposited on the sheet surface. This fills any tiny pores and surface irregularities. This creates a smooth surface, as is required in automotive manufacture, for example. The hot-dip galvanizing lines at Salzgitter Flachstahl produce hot-dip galvanized sheet. The strips of various coils are welded together to create a continuous strip. During welding, the entry loop accumulator supplies the plant with material without interrupting the galvanizing process. The strip is then brought up to temperature before being dipped into an approximately 450 degrees Celsius hot liquid zinc bath. The desired coating thickness is adjusted by means of compressed air jets. In the strip coating plant, galvanized steel strip is finished with organic coatings. Synthetic resin varnishes, plastics dispersions or foil laminations are applied according to customer specifications. The finished products warehouse contains up to 350 different grades of steel products. Salzgitter Flachstahl products are used in very different industries and applications, including structural elements and building engineering, and for so-called tailored blanks, namely special sheet for the automotive industry. Salzgitter AG products are used all over the world. Some of the steel products produced at the Salzgitter site are distributed via its own trading organization. Salzgitter AG operates an international sales network around the globe that supplies customers with steel products. As the production of pig iron, steel and steel products requires a reliable energy supply, Salzgitter Flachstahl has its own power station. Here the process gases generated in the steelworks are fed back into the energy cycle. In addition to process steam for the production sites, it also generates electricity. This combined energy utilization system achieves maximum energy efficiency. Despite the development of numerous new materials, steel will continue to play an essential role in the future, which is why Salzgitter AG maintains its own research and development corporation. By collaborating with technical universities, users and customers, the R&D department researches and develops solutions for product and process optimization. This ensures ongoing, client-oriented and application-focused product development, the fundamental basis for utilizing steel, the most important construction material both today and in the future. Steel. An outstanding material, particularly from an ecological point of view, as it is completely recyclable with almost no loss of quality. Iron and steel products were being reused well before recycling became a buzzword. Steel scrap is a valuable raw material. The recycling of steel makes a key contribution to the conservation of resources, both today and in the future.